Okay, students, welcome to the last part of this section. And this is where we're going to do a little bit more complicated examples and some word problems. So let's kind of talk through this diagram here and see what we have going on here. So I've got a big right triangle, or I'm sorry, this is not necessarily that wouldn't actually be a right angle because of these two right here. So that's not a right angle. And if you don't see that, let me show this to you. So like, remember, every angle in a triangle adds up to 180. So if I did 180 minus the 63 and minus the 39, what would happen? That's a 78-degree angle. So that whole angle right there is 78. But what you do have is you have two right triangles. So this is a 90-degree angle there, and so is that. And the reason for that is because a straight line makes a 90-degree angle. So here's kind of the approach I'm thinking on this. We're supposed to find the total side x there. Well, what I'm kind of thinking is I think we could find this little piece because you would have this right triangle here. And I think you could find this piece right here because you have this right triangle there. So we're actually going to just break this up into two right triangles, and then if we can find the yellow part and the blue part, what would we do to get the final answer? Yeah, we would just add those two together. Okay, so let's kind of start this like this then. For step one, let's just draw a picture of this triangle here. So we have a 63-degree angle, and I'm going to call this little piece right here, let's just call that x. Okay, and then this side of the triangle is 82. All right, now we have enough information to figure out what x is just by doing some basic trigonometry. All right, so like I was showing you early in this section, well, focus on the angle and talk out what you have. And you got to know which trig function you have. So in relation to 63, what you have is this is the side opposite, and then that is the side adjacent. So the trig function that's opposite over adjacent is the tangent. So what you would say is the tangent of 63 degrees is equal to opposite 82 over adjacent x. Okay, and then that would give you something you got an equation you can solve. So again, you can cross multiply on this. Okay, so if you do that, you would have x times tangent of 63 is equal to 82 times 1, or 82. Okay, you're solving an equation. What do you need to do to get x by itself? You need to divide both sides by tangent of 63 degrees. Okay, then you're just going to go to your calculator to finish this up then. So that would give you x, and then we just need to do this in the calculator. And when you do this in the calculator, you want to make sure again that you're in the right mode. I'm going to press my mode button and see I'm in degree mode, so I'm good to go. All right, so what I'm going to do then is just do this, 82 divided by tangent of 63. And we'll round that, I guess, off to 1 decimal. Okay, usually I tell you what to round it to. I didn't on this handout, though, I think. So we'll just say that's 41 point, the 7 has to go up to 8. So we're going to say 41.8. Okay, so that's what we get there. Okay, so this piece of the problem right here, x is going to be 41.8. All right, so that's how you start. Now, step 2, what I'm going to do is we're going to look at this triangle. Okay, the triangle right there. So I'm going to draw, just kind of sketch that triangle, and I'm going to write down everything that I have here. Well, we got a 90-degree angle there. We have a 39-degree angle here. And again, this side is 82. And then what I'm going to do is I'm going to call this piece, that base right there, I'll call that y. And then again, just like the last problem, we should have enough to solve that. So again, what you want to do is just talk this out. And if I talk this out, this time I've got this angle, I have a side opposite, and I have a side adjacent. So it's exactly the same as the last thing. You'd do a tangent. So you would say the tangent of 39 degrees is equal to opposite over adjacent. Okay, then you would fit that into your ratio, so you would have 82 over y, just like the last problem. Solve it exactly the same way. Cross multiply. You would have y times tangent of 39 is equal to 82 times 1, or 82. Then take your calculator. We're going to divide both sides by tangent of 39 degrees. And then that should give me approximately what y is then. Okay, so I'll take my calculator and do the same thing here. So 82 divided by tangent of 39, and I'll round that to one decimal, so let's take that as 101.3. Okay, like that. Okay, so what we have is we've got what we need to do, what we need. Okay, so how do you find what, I probably could have used a different variable on that, but I'm looking at the total side, so step 3, we just do 41.8 plus 101.3 to get what that total big side is that you're asked for. So I'll take that on my calculator, 41.8 added to 101.3, and then that'll give me the answer. Okay, so the final answer is 143.1 units. Okay, so that is the final thing. Okay, all right, so that's how that goes. All right, does that make sense? Okay, so you're doing, two triangles, so you can kind of split it up into two parts to find that. Okay, later on in the semester, we probably could do this in a little bit different way, possibly when we learn law of sines, but it's not too bad to just use two triangles on that. Okay, so let's go down this next one, and let's see what we're getting ourselves into on this one. Okay, so we've got this diagram, and with this one, let's see, we got a right triangle here. So see, that's a right triangle. There's another right triangle. Where is it? The big one is also a right triangle. So we only know how to work with right triangles. So let's kind of think about this a little bit. I'll kind of show you what I'm going to do on this. I'll use a little bit different variable this time on here. So here's kind of my thought. Okay, we could find this piece right here easy enough. Okay, we could find that because we have a right triangle and we have an angle and we have a side opposite. So it'd be a lot like the last problem. So we can do that. So let's just call this, y on this, and then that'll be our step 1, is to find that. Okay, now the other thought that I have is, well, we have this big right triangle right here, so we could find this whole entire side, I think. Okay, I think we'll have enough information to do that possibly. So think about this. If we found the blue part and we found the yellow part, then what would you do to find the leftover part? Right, you would subtract. You would do the whole minus the part would give you the rest. So that's kind of my strategy I'm going to do on this. So what I'll do here is I'll say, okay, the whole entire side right there, let's call that z. Okay, so that's just kind of a strategy I see. I'm sure there's other ways to do this, and I know later in the semester when we learn what's called law of sines, you'll have another way to do this. Okay, so here's kind of what I'm going to do first of all. All right, I need to find this angle right there. And actually, I don't need to do that yet. I will in a minute. So let me just kind of talk through this then. So we're going to look at this triangle here. Okay, you can kind of see what I'm highlighting there. Let's just sketch out that triangle. Okay, and let's write down what we have. Okay, so we have 115. Okay, this base we decided to call y. And then we have that angle as 56 degrees. So we should be able to easily find y on this by doing the tangent. So again, if you look at angle 56, you have opposite and you have adjacent. So again, that's going to be a tangent. So what we would set up is we would have tangent of 56 degrees is equal to 115 over y. And then we're going to cross multiply. So what you want to do is go ahead and cross multiply that. So we'd have y times tangent of 56 degrees equals 115 times 1, or 115. Okay, then what you want to do with this is you can divide both sides by tangent of 56 degrees. Okay, that will divide out, and that will give you what y is. And of course, we just need to go to the calculator to get that taken care of then. Okay, so I'll just move my calculator over here. And what I'm going to do is 115 divided by the tangent of 56 degrees. Okay. All right, so that's going to give me, again, one decimal. We're going to say that's about 77.6. Okay, so we got that piece right there. So that's kind of the first thing we need to focus on. All right. Now, when we get into step 2, we're going to try to find this side z. So what we're going to have to look at is this big right triangle. So let's write this big right triangle here and see what we know so far. So in this big right triangle, we know that angle's 35, and we know this side's 115, and then we know that side z. So actually, I don't need to find these angles. Originally, I thought maybe we'd have to do that, but we don't. See, we have, anytime you have two sides of two parts of a right triangle, other than the 90-degree angle, then you can solve it using trigonometry. So this is exactly the same thing. You have, talk this out. In relation to the angle, you have opposite over adjacent. So once again, you're going to do the tangent, okay? Okay, and you never know which trig function you're going to use. You just have to, it depends on what I give you, okay? So we'll write this like this. The tangent of 35 degrees is equal to opposite, 115, over adjacent, where we're using the z. I put the tangent over 1 just to see that you have a proportion, and you're going to cross multiply. Okay, so I cross multiply. I'm going to have z times tangent of 35 degrees equals 115 like that. Okay, then I divide both sides by tangent of 35 degrees. And then I'll go to the calculator, and then we should be able to get the whole problem put together here, okay. All right, so I'm going to go ahead and do this on my calculator. So I'm going to take 115 divided by tangent of 35, and we got it. Okay, so let's see, that is going to be 164.2. Okay, and I expected that to be bigger. So see, what we have is we have these two parts. We got y is this, we have z is this. Now step 3, what do? Okay, z is the big part, y is the small part. So what you do is, if you want to find x is just going to be z minus y. I think of this as the whole minus the part gives you the rest. Okay, so z was 164.2, y was 77.6, and then that should give the answer to the problem. Okay. Okay, so I'll go ahead and do that, and that'll close that problem off. 64.2. These problems are kind of fun, you know, because you got to think a little bit about it and kind of come up with a strategy. These aren't too hard, but they can sometimes, you know, be pretty challenging to do, depending on what the situation is. Okay, so that'll take care of that. Remember, always pause if you kind of get behind, or if I get to going too fast, just pause. You can also, on problems on here, if you think you already know how to do an example that I'm working out, you can go ahead and work it out, and then just, you know, fast forward a little bit in my video to tell if to see if you're on the right track. Okay, so you can always do that. Okay, so let's go to the next page. Now, I want to introduce you to what we mean by angle of elevation and angle of depression, and this shows up in word problems quite a bit. So it's real simple. You're an observer, and this is what you would call your line of sight. So this line right here, it's worth writing that down. That's called the line of sight. So that would be if you're just looking straight and it's parallel to the ground. Okay. Well, angle of elevation would just mean you're looking at an object that's above you. Okay, like you're looking at the sun, or you're looking at the cloud, or looking at the top of a building or something. So this angle here, we call theta. That would just be your angle of elevation. Okay. Angle of depression means you're looking down at something. Okay, so you're, like right now I'm sitting on a kind of a high chair in my kitchen, and I'm looking down at the kitchen floor. That's an angle of depression. So it goes that way. Now, they're both positive angles. Don't get confused on this. You would still use a positive angle because we're going to use triangles on this. So don't worry about the counterclockwise, clockwise. That doesn't make any difference, okay? So that's your angle of elevation. That's your angle of depression, okay? All right, now what we're going to do is we're going to do some application problems, and just a few of these. So really what you always want to do, the difficulty with students on this usually is getting the diagram drawn and getting the triangle drawn right, because you have to interpret what the sentence is telling you. So you always want to do these things. You want to read the problem, obviously. You want to try to draw a diagram, and you're going to have a right triangle in here, so you want to label those parts of whatever that right triangle is. And you might have more than one right triangle like we had in the previous example. And then typically some basic geometry and trigonometry. There should be enough information given in the problem to figure out that part. Okay, so let's go down to this problem here and let's read this, and then let's take a look at that. I'm going to read it first of all. It says, from the top of a lighthouse, 18 meters high, the angle of depression to a nearby sailboat is 10 degrees. How far from the top of the lighthouse is the sailboat? Okay, I have to have a picture. I'm very visual. I need to see the triangle and what I'm doing. Okay, so let's just kind of do this. Okay, you don't have to be a good artist or anything. I just kind of try to get the idea. So here's my lighthouse, okay, like that. So we have that. Now, from the top of that lighthouse, you know, somewhere in here, you see a sailboat down below you somewhere. So here is my pretty artistic sailboat. Okay, what's that artist who has the afro and says a happy tree and that? Well, this is my happy little sailboat. Okay, I forget what I can't remember his name, Ross or something like that. He's on PBS a lot. So anyway, what we're going to do is we're going to do this. So we're going to draw a triangle out of this, and I'll use this red to kind of show that. So we got that. And what you're doing on this is you would have your line of sight kind of going like that. That would be parallel to, I guess, to the ocean or the lake or whatever's down there. So that's your line of sight. And then what you're doing is you're looking down at that sailboat. And then what it says, there's the key things it says on this problem is the top of the lighthouse is 18 feet high. So you're going to have a right triangle right here. And you're going to have these pieces. This piece right here is going to be the 18 meters. And then the angle of depression, that's what sometimes students don't do right. That's the angle of depression. So if you look at the diagram above, it's that. It's not that, okay? Or it's not this. A lot of times students want to think that's the angle of depression. That's between line of sight and whatever you're looking at. Okay, so what we have so far is we have this. We have a right triangle. And then the question is, how far from the top of the lighthouse is the sailboat? So you're actually looking at this hypotenuse right there. That's what it says. How far from the top is the sailboat? Okay, now what I'm going to do, a lot of times when I do this diagram, I like to just draw my right triangle, and I like to label all the parts. Okay, so we know that's 18 meters, and then we know that's X. That's what we're trying to find. Okay. Now, we got to know either this angle, you have two choices. You either figure that angle out or you figure that angle out. Because you're going to have an angle in here. And you have enough information to figure that out. One thing you could do is this angle right here would just be 90 minus 10. So that angle right there would be 80. Okay? And then this angle, remember these two angles add up to 90. So 90 minus 80 would be 10. Now, there's something that's kind of nice to know on this, and maybe some of you already knew this. This angle and that angle are the same. And any time that you have two parallel lines, and if you cut it with a line, this angle and that angle are the same. Those are called alternate interior angles. Where do you learn that? In geometry class. If you take that in high school, that's where you learn about alternate. Can't talk it right at the same time. What I meant to say was alternate interior angles. That's worth writing down because that's a vocabulary word or concept that you may have to look up a little bit and review if you need to. Okay? All right, but that's what you use that alternate interior angle theorem quite a bit in trigonometry. So what I'm going to do is I'm going to use that is 10. Now you could do this problem in two different ways. You could use the 80 and use a different trig function if you wanted to, okay? So it looks like we got everything we need. We have our two parts of the triangle and we have the unknown. So I'm going to highlight this and we're just going to focus on those three things there. So in relation to 10, what do you have? This is the side what? That's the side opposite. What is x? That's the hypotenuse. Good. Okay, so which trig function is opposite over hypotenuse? Okay, that would be the sine. Remember, you got to get those definitions down. So we would say the sine of 10 degrees is equal to opposite 18 over x. There you go. If you can solve that, it's a proportion, you got the answer to the problem. So I'm going to put that over 1, cross multiply, so that's x times sine of 10 degrees equals 18. Then I can divide both sides by sine of 10 degrees and then get the calculator out, and then I got the answer. Okay, so let's get the calculator out and let's see what we get. Okay. Right, make sure you're in degree mode when you do this then. Okay, so I'll go 18. Oops, I'll clear that off. I got 18 and divided by sine of 10 degrees. And then we'll round that off, I guess, to maybe 1 decimal. Okay, so the answer to the problem is 103.7 meters. Okay, that's it. Okay, now to me, this is interesting. Okay, this is kind of what you get into. We can use trigonometry to indirectly measure things. Okay, there's a device that a person could do, and even some smartphones have apps like this now, so you could actually measure that angle. Okay, just by pointing, there's kind of a angle measuring device. So if you already knew you were 18 meters high, well, you could just measure that angle and then you could figure that distance. Your other choice would be to take like a rope and to tie that rope like that and measure that. That's a lot more work than trigonometry is. Okay, so trigonometry saves you a lot of time, see. So surveyors, engineers and stuff use this all the time. This is how we can measure the distances between two objects that are kind of hard to measure directly, see. Okay, so that will take care of that. I'm going to go to this last page. And what I'm going to do is I'm going to do one more example, and then I'll let you kind of finish up by doing one yourself. Okay, so let's see. Let's read this. So we have a ranger's tower is located 44 meters from a tall tree. So that's the ranger tower. That's obviously the tree, and then that's the distance. It says from the top of the tower, the angle of elevation to the top of the tree is 28. So that's saying you're looking from here to there, so that's an angle of elevation, so that's 28 degrees. Okay, the angle of depression to the base of the tree is 36, so that's right there. Now see, I went ahead and just did the diagram on that. Sometimes you will have, when you're doing these problems on homework or stuff, sometimes you'll have the diagram, sometimes you won't. Okay, and the hardest part a lot of times is getting that diagram down. Okay, all right, well, the question is how tall is the tree? So what we have is we're going to look at this piece right here, and we'll call that x, so that's what we're trying to find. So again, you want to think about what we would have to do to figure this height of this tree out. So first of all, you actually, if you think about it, you have 3 right triangles. This thing right here is a right triangle. And it might be possible to figure out that piece right there somehow. We may have enough information. We're going to find out in just a minute. We also have this triangle here, and we have an angle, and we have enough information here to find what x is. Okay, so my thought process, let's see if we could figure this little piece out there, and then let's see if we can figure this piece out here. That piece there should be the same as x. So my thinking is, what I want to do is I want to find that piece right there, okay, and I'm just going to call that, I think there's already a letter y in there, so I'm going to call that piece right there y, the part I highlighted in yellow, and then this part right here, I'm going to call that something like z, okay. So what are you going to do with that then? If you know y, you know z, how do you find the whole height of the tree? Right, you add those together, okay? So again, to me, it's kind of helpful to look at your triangle. So let's start with this upper triangle, and let's kind of see if we have enough information to figure this out. Okay, so that's a 28-degree angle. That's that angle of elevation. That's the unknown. Now, do you know what this base is? Do we know that? Yes, it's 44. Okay, that is going to be the same as that. Because that tower is, we're assuming it's straight up and down, so it's not slanted. So if that's 44, so is that. So yeah, that's enough information to figure this out. So look at your angle, look at your other two parts. Again, talk it out. In relation to 28, that's the side opposite. This is the side adjacent. Okay, which trig function do you use for opposite over adjacent? Use the tangent. So we'd say tangent of 28 degrees is equal to y over 44. Okay, there's a basic proportion, so cross multiply. We're going to have 44 times tangent of 28 equals y times 1, or y. Then we divide both sides by tangent of 28. All right, and we'll have approximately what y is when we go to the calculator. So see, all these problems, once you get it set up, it's always kind of the same basic idea. Okay, so I'm going to go then it looks like I've got, what in the world did I just do? Some of you probably noticed this. Sometimes I just get to, it's like I'm on automatic pilot when I make these videos, and I just kind of not paying attention to what I do. Okay, I'm going to erase this, okay, and show you. I did something that was ridiculous. So let's cross multiply. Y times 1 is y. Hey, that's what we're trying to find anyway. Okay, then we go this way, so that would be 44 times tangent of 28. Okay, so if you cross multiply, then it's already solved for y. All right. I looked at that and I thought, what in the world was I doing? So that would be 44 times. You can leave off the times and just put 44 tangent 28 on these calculators. Calculator knows what you're doing, so that would be about 23 point, and we'll round that to 4 meters. Okay, so anyway, we got that. So they got that key piece of the problem right there. Okay. Now, the second thing we're going to do is we're really going to look at this triangle here, okay, or this one. It's all the same. I'm going to go ahead and just write this right triangle out right here. So in this right triangle, you would have Z here. Your right angle would be there. You'd have 36 degrees there, okay? And if this is 44, so is this. Okay, so that's what you got to understand. So you got 44 there. You got the angle, and then you've got the unknown. So it's the same idea. So when you reason this out, you look at this. In relation to 36, you have an opposite, and you have an adjacent. Okay, tangent's shown up a lot on these examples, but remember, it can be anything. But you always want to use sine, cosine, or tangent. You don't want to use any of the other three. When you're solving word problems, do sine, cosine, and tangent. Okay, so when we put this together, we'll have the tangent of 36 degrees equals side opposite Z over adjacent 44. And I put that over 1, and then this is just like the last problem. So I cross multiply. Z times 1 is Z. Go the other way. That's 44 tangent of 36 degrees. Okay, and I can do it on the calculator, and then I can round that off. So 44 tangent 36 is going to give about, and now this one you got to be kind of careful about. How do you think you'd round that? You got the 9. The 9 has to go up where? Yeah, it goes up to 10, but the 10 makes the 31 go to 32. Sometimes students don't round that right. That's the way you would round that to 1 decimal, is like that. Okay, the 9 can't stay 9. It has to go up. The only place it can go to is 0, but that causes the 31 to go to 32. That's kind of like a regrouping there. Okay, so we got this. Now what do? We found y, we found z, we add those together. Okay, so to finish up the problem then, we would just say, okay, that big side x we found there, we just need to do the 23.4 meters plus the 32 meters, and then that'll give us the answer to the problem. Okay, so 32 plus 23.4 is going to give 55.4 meters is the final answer to the problem. Okay. All right, so that is it right there. That is your answer to the problem. Okay, look over that a little bit if you need to. These problems are kind of fun and they're very practical. When I've done home improvement projects in my home, a lot of times I do a little bit of trigonometry if I need to indirectly measure an angle or something. So, it works out cool. Okay, so I'm going to let you pause the video and see what you can do on this one problem, and then that'll wrap up this section. Okay, so put it on pause and give it your best shot. Okay, so moment of truth. See what you did. Okay, I got 418.1 feet. I'll talk through a little bit, and you may have to study over this. This was not too hard. The idea was you have a right triangle here with an angle 70. The base of that's 150. Okay, that's the same as the distance the truck is from the building. And then I'm going to find this piece X here. So I drew this triangle out over here. I have 70, X, and 150. The tangent of 70 is X over 150 because that is opposite over adjacent. So we're using tangent again. I cross multiply and solve that. So I get 412.1 feet. Okay, but the question is, how high is the ladder reaching the whole entire building? So you got to also consider that 6 feet. So I do this plus 6, and then that's the final answer. That's the way I interpret that problem. All right, what do you think? All right, so a key thing on these word problems is get your triangle drawn good, get your diagram drawn good, and you got to know your trig functions. You need to make sure you got the SOHCAHTOA stuff down and memorized, because that's what this section's all about, right triangle trigonometry. Okay, hope you enjoyed this and hope you do well when you're working out problems. Let me know if you have any questions. Bye-bye.